We're going to continue with section 8.3. We're finding the maximum and minimum values. So the y-coordinate of the vertex of our graph f of x equals ax squared plus bx plus c is a maximum value when a is less than 0. In other words, when a is negative. So I'm going to talk about this graph here on the left side. When our a is negative, it causes our parabola to point down because there's a reflection over the x-axis, all because that a is negative. When our parabola is pointing down, look at where the vertex is on this parabola. It's at the very, very top of this graph. These arrows mean that this graph goes down forever, so it's never going to stop going down, but this point where the vertex is the very highest point on the graph, which makes it the maximum. The minimum value of a function happens when a is greater than 0, or in other words, when a is positive. If the a is positive, the parabola points up, and now look at the vertex. The vertex is at the very bottom, making this point the minimum point of the graph. So we're going to take a look at example 3 step by step. So they're going to give us an equation in standard form, and we want to say if it has a maximum or minimum, and then we're going to find that value. Here's our equation, f of x equals negative 4x squared minus 24x minus 19. The first thing that I want to look at is the a value here. Since our value of a is negative, that means that our graph is going to be pointing down. When our graph points down, the vertex is at the top of the graph, making this graph have a maximum value. So we're going to find that maximum value, which is the y-coordinate of the vertex. Well, in order to find the y of the vertex, I have to find the x of the vertex, and I'm going to do that by using x equals the opposite of b over 2a, that formula that we were using. So in our equation, the a is negative 4, the b is negative 24. Let's plug it into our formula. The opposite of negative 24 over 2 times negative 4. This becomes positive 24 divided by negative 8 is negative 3. That's the x of the vertex. So now we're going to find the y of the vertex by taking negative 3 and plugging it into both of these x's in our equation. So negative 4 times negative 3 squared minus 24 times negative 3 minus 19. Again, don't forget order of operations. Do negative 3 squared is positive 9 first, and then times it by negative 4, and then multiply these and subtract 19. We get 17. So therefore, the maximum value is 17. Let's look at another example, and let's let Big Ideas explain.
Tell whether the function f of x equals 5x squared plus 15x minus 10 has a minimum value or a maximum value. Then find the value. For f of x equals 5x squared plus 15x minus 10, a equals 5. Because a equals 5 and 5 is greater than 0, the parabola opens up and has a minimum value. To find the minimum value, find the y-coordinate of the vertex. First, find the x-coordinate of the vertex. Write the equation for the x-coordinate of the vertex, x equals negative b divided by 2a. Because a equals 5 and b equals 15, substituting 5 for a and 15 for b gives x equals negative 15 divided by the quantity 2 times 5, which simplifies to x equals negative 1 and 5/10. Then evaluate the function when x equals negative 1 and 5/10 to find the y-coordinate of the vertex. First, write the function. F of x equals 5x squared plus 15x minus 10. Substituting negative 1 and 5/10 for x gives f of negative 1 and 5/10 equals 5 times the quantity negative 1 and 5/10 squared plus 15 times negative 1 and 5/10 minus 10, which simplifies to 11 and 25/100 minus 22 and 5/10 minus 10, or negative 21 and 25/100. Because the y-coordinate of the vertex is the minimum value of the function, the minimum value is negative 21 and 25/100.